Welcome to VVSM Academy. Today I would like to discuss about the real number system in mathematics. A real number is a value of a continuous quantity that can represent a distance along a line. The real numbers include all the rational numbers such as the integer and the fraction, and all the irrational numbers such as root 2, 1.414 decimal number, the square root of 2, an irrational algebraic number. Real number system. Chapter is introduction, Surds, 4 basic operation on Surds, a rationalization of Surds, division algorithm. The meaning of the word surd is twofold. In mathematics, it refers to a number that is partly rational, partly irrational. It is known that all Khwarizmi identified surds of some special in mathematics, and this mute quality of theirs. In or around 825 AD, he referred to the rational number as audible and irrational is inaudible. It appears that the first European mathematician to adopt the terminology of surds, surdus means deaf or mute in Latin, was Gerardo of Cremona, 1150. It also seems that Fibonacci adopted the same term in 1202 to refer to a number that has no root. Surd is defined as positive irrational number of the type nth root of x, where it is not possible to find nth root of x, where x is positive rational number. Al-Khwarizmi was the most illustrious and most famous of the ancient Arab mathematicians. He was likely born in Baghdad, now part of Iraq. The algebra treatise Hisab al-Zard wa Muqabala was the most famous and significant of all Al-Khwarizmi's works. Another important work by him was his work Sindhind on astronomy. Surds. We know that root 2, root 3, root 5 are irrational numbers. There are square roots of rational numbers which cannot be expressed as squares of any rational number. Cube root 2, cube root 3, cube root 7, etc. are the cube roots of rational numbers which cannot be expressed as cubes of any rational number. This type of irrational numbers are called surds or radicals. If a is a positive rational number and n is a positive integer such that n root a is a rational number, then n root a is called surd or a radical. The general form of surd is n root a. Root is called a radical sign, n is called order of the radical, and a is called the radicand. Index form of a surd. Think and answer. The following examples are: fifth root of 8 can be written in index form as fifth root of 8 is equal to 8 to the power of 1 by 5. In the following table, the index form, order and radicand as some surds are given. Surd, index form, order, radicand. Fifth root of 5, index form is 4 to the power of half, order is 2, and radicand is 5. Similarly, all these things. A reduction of a surd to its simplest form Consider the surd root of 50 can be reduced to 5 root 2. 5 root 2 is the simplest form of 50. Like surds and unlike surds classification. Root 5, fourth root 5 minus 6 root 5 are like surds, example. And root 10, cube root 3, fourth root of 5, cube root of 81 are unlike terms. Pure surds. If we have pure surds, mixed surd can be converted into pure surd, and a pure surd may or may not be converted into mixed surd. Loss of radicals or loss of surds. For a positive integers m, n are positive rational numbers a, b, we have nth root a to the power of n. Like this. These are the loss of radicals. You see, real number system continues. Convert the following surds into index form. Index form, we write the given surds as follows. Root 7 is equal to 7 to the power of half. Fourth root of 8 is equal to 8 to the power of 1 by 4. Cube root of 6 is equal to 6 to the power of 1 by 3. And eighth root of 12 is equal to 12 to the power of 1 by 8. These are the important index form. We express the following surds into simplest form. Cube root 32, find the factors. 8 fourth 32. So that is cube root of 8 and cube root of 4. That is equal to cube root of 2 to the power of 3 and cube root of 4. That is equal to, this is 2 into cube root of 4. Like this, the real number system continues. Surds into its simplest form. Express the following mixed surds into pure surds. Examples have given. You please put the sums using the given data. Identify whether root 32 is a rational or irrational. Root 32 can be written as root of 16 into 2. That is equal to root 16 is equal to 4 and root 2. Hence 4 is the rational number and root 2 is an irrational number. Therefore, 4 root 2 is an irrational number and hence root 32 is an irrational number. These are the solutions. Identify whether the following numbers are rational or irrational. 4 basic operations on surds: addition and subtraction of surds. Solve all the problems given. Multiplication of surds. Root nth root a into nth root b is equal to nth root ab. Like this, you can solve the problems given. Division of surds. Root na is divided by nth root of b is equal to nth root of a by b. Like this, you can solve the problems. When the order of the surds are different, we convert them to the same order and then multiplication or division is carried out. Comparison of surds. Convert the irrational number to the same order. For example, take the LCM of 2, 3 and 4. Finding the LCM and solve the problem. That is 12th root of 3 to the power of 6. And the product 3 to the power of 6 is equal to 12th root of 7 to 9. Which is greater? Take the LCM and follow the things. Write the irrational numbers, ascending order and descending order. Please solve the sums using LCM and you can take exercises given. Solve all the problems in the exercise 1.1. when the denominator of an expression contains a term with a square root or a number under radical sign, the process of converting into an equivalent expression whose denominator is a rational number called rationalizing the denominator. Rationalizing the denominator. 2 by root 3, rationalizing the denominator, which is simplified equal to 2 root 3 by 3. Similarly, rationalizing the denominator, solving the problems, all relates to book. Try. Like, share, subscribe. Thank you. My dear friends, I would like to work out the mathematics problems relating to rational numbers and irrational numbers in Surds. Thank you.